Good morning. Today we're going to be working on multiplying binomials, also known as FOIL or the box method. Throughout the year, this is the most common mistake that I see happen, so if you can master it early, that's fantastic. And if you can't, then come back and watch this again. YouTube or Google how to FOIL or how to box method or how to multiply binomials. You can find a million different explanations. This is just another one, but hopefully it helps so that as we see this appear over and over week after week, that you can do it without even writing anything down. Your brain can just know, oh, I know how to FOIL, or I know how to box method this, or I just know by looking at it what these binomials turn into. So let's get started so that we can just work a couple practice problems. If you look at this paper, you can see there's probably a lot of practice, probably 8 or 9 practice problems for you to work on. We'll do 1 or 2. And then if you want to practice them, if you need more problems, you can literally just Google FOIL worksheet, and there's thousands of them online. So let's get started. FOIL stands for first, outer, inner, last. You can see that right there in the pink words right there. You've got your first terms, your inside, your outside, and your last. And some people are like, well, what does that mean? It's basically the same thing. If you can think back to 3rd grade or 4th grade, whenever you did this thing called the distributive property, that looked a little bit like if you have an A and then parentheses and then B plus C on the inside. If you remember what you do with those, you take the A and you distribute it. You draw those little rainbow arrow things across. Every term gets an A. And that's what the distributive property means. Here, I'll label that. Distributive property. Well, FOIL is no different, except now we've got 2 things to distribute. So when we look at the first, these first pink arrows right here, I'm going to highlight them. When we look at the first terms, we're distributing that AX across the parentheses over to the CX. And that's multiplying the first terms, or distributing, just like the distributive property from a long time ago. And then we just do it again with the thing called outside. So, and the reason it's outside is because if you picture this as a sandwich, AX is on the far left, and D is on the far right, so they're the outside terms. So we take the AX and we distribute it, or we multiply the 2 outside terms by the D, and that's where they get their second term, the O, which is AX times D. And then you do the same thing with the B, and you're distributing it twice, and you get a 4-term solution. Now, a lot of times with those 4 terms, we can combine them with combining like terms, which we'll see when we start getting some practice problems. So I think let's just jump right into it and see if we can apply this. And if you have questions or if this isn't super clear, just let me know. And I'd be happy to work more or do some examples. So let's skip the box for right now, hop down to example 1, and just FOIL this thing. So what's the F stand for? The F stands for first. You don't have to write this every time, but I'm going to anyways. And I'll do it in different colors. So watch this. We'll do first. The first terms, or the leading terms of each binomial. So what's the first terms? It'd be 3x times 5x. And if you think back to multiplying these terms, think back to the laws of exponents. We know that 3 times 5 gives us 15. And x times x gives us x squared, not 2x. If you say 2x, that's x times 2. All right, now let's hop over. So FOIL first, outer. Let's do this in blue. Outer terms. So what are the outer terms here? We've got 3x times... Ooh, we got a little minus sign there. That's a little weird. So another way we can write minus 3. This is a common thing that we do a lot of times. Is it's the exact same thing. If we zoom in real big, I like to do this a lot because it helps me remember which term to bring to the FOIL. You can rewrite minus 3 as plus negative 3, right? So 5x minus 3 and 5x plus negative 3 are the same thing. It's taking 3 away from 5x, either way you say it. So now we know which term to FOIL. So we've got 3x times a negative 3. And if you think back, does the negative 3 multiply by the x or the 3? It hits the 3 and we get negative 9x. All right, let's switch to green. Try to go a little faster. It's because it's doing the same thing over and over. So we got first, outer of the sandwich. Now we got the inner of the sandwich, FOIL. So now we go inner boop, boop, boop. I'll write it over here. Enter, boop. 4 times 5x gives us 20x. If you don't like that, I'm sorry. And then last but not least, we've got last. So this one's harder to draw, but I'll just do a little purple arrow like this. Boom, boom. The last terms of each binomial are 4 times. Keep that negative sign there, it's good. -3. So we've got last as 4 times -3. 4 times -3, -12. Perfect. All right, now what do we do with all these things? Let's go back up and look. Do we add them? Do we subtract them? Do we multiply them? We've got 4 distinct terms, or 4 new terms. All right, look at that. They just add them all together, and they say, hey, that's how you do it. That's how you distribute. So we're just going to take a plus sign, addition sign, and throw it in between each of the terms. Boom. Just like that. And are we done? Maybe, maybe not. Is it true? Yes. Could it be simpler? Probably. Let's look at it and see. We're going to do this thing that we like to call combining like terms. So combining like terms is when you take terms that look the same, that have the same variable and the same exponent, and combine them together. So let's look at this and see. The variable is x for the first term. The exponent is squared, or 2. I see no more x squareds, so it's all good. We're just going to rewrite it. No combining to be done. All right, let's look at the second term. The variable is x. The exponent is, if you remember this back from the laws of exponents, which there's another video if you want to go watch laws of exponents, we talk about this. Talk about the invisible one that exists on every single variable ever. Boop, boop, boop. So now we've got 2 variables that are identical with exponents that are identical, so we can combine those together. So if I've got -9 cookies, or -9 t-shirts, or -9 x's, and I've got +20 cookies, t-shirts, x's, whatever you want to call them, and we combine those together, combine the like terms, we'll take 20 minus 9 and end up with, oh, I'll do it in the color. Oh, that's a new color. 20 minus 9 gives us 11 x's, or 11 cookies, or 11 t-shirts, whatever you want to call them. So you remember, a variable is just taking the place or holding something there. We don't know what x is, but we know there's 11 of them. And then last but not least, we've got our -12, which I just took out the plus sign because we said earlier, plus -12 is the same thing as -12. And there is our FOIL. All right, but I want to, some people say, oh, that's too confusing, too many colors, too much is going on. And a lot of students, especially ones that do not remember this from high school or having trouble with it, like to use the box method instead. So I'll show you the box method and then we'll be done. Let's look at this real quick. We're going to take the figure 1. We're going to take the example from figure 1 and throw it into this box. So we're going to take the first binomial. Let's look at this top square right here. We're going to take the first binomial. I'm going to underline it in green right there. We're going to take that green binomial and we're just going to write it on the top of the box. So AX, and then I'm going to take the, whether it's a plus sign or a minus sign, I'm going to take it on the other side of that invisible line that keeps going up. I'm going to go plus B. Okay? And then I'm going to take that second binomial, I'll do it in blue. See this blue binomial right here? Take that and throw it over here, CX. I'm bringing that plus sign. The plus sign doesn't matter, but when it's a minus sign, it matters a lot. So I'm going to bring it over with us. Plus D. And now we're going to do the same thing. Literally each of these, and I could write it in the top corner, each of these sections of the box co-align with the F, the O, the I, the L. They're exactly the same. So like this first section is technically the first 2 terms just being multiplied. So we're going to get the same term, AX times CX is ACX squared. Which I know looks a little weird, but it's the same term as before. Let's look at this. BX, or actually here, let's draw a line so we can see what we're multiplying. So if we do outside next, which one would be the outside? The A and the D. So let's take this and we'll say this one bottom left is the outside. So we're going to take this AX and this D and multiply them together. And you'd probably end up with something like A times D times X. Then we're going to do it again. This one would probably be the inside. And we're going to multiply them together. You know, I'm taking that cx over there and multiplying it by this b right there. I know it's a lot of lines, but like we said earlier, every term is getting multiplied by every other term, and that's it. It's like a double distributive property. And then last but not least, this is the easier one. You can take this d that's by itself and this b that's by itself and multiply them, and you get b times d. Okay, and then what do we do with the 4 boxes? All you do is you take them and you add them all together, just like we did for the last term. So for the variables, for that really confusing one, it looks like acx squared plus bcx plus adx plus bd. That might look a little confusing. Let's do it with the same numbers we just did, and then we'll be done forever. And you can practice if you want to practice. If you got it, great. But you will see this 100 times, 1,000 times this year. So it's really important to know how to do FOIL or box or multiply binomials if you don't even want to call it anything. All right, so let's take those same numbers. We're going to take 3x, and like I said, we're going to put the plus sign on the other side, plus 4, and then 5x minus 3. All right, here's FOIL. So what's 5x times 3x? Same problem we did a second ago, 15x squared. And we got that just by multiplying the two numbers on that box section. Let's drop this 4 in. Positive 4 times 5x should give us something like 20x. Sweet. Drop this 3 all the way down. Drop this 3 over. 3x times negative 3 gives us something like negative 9x. Cool. And last but not least, you can draw our arrows outside if you want to so it's not as messy. Boop, boop. 4 times negative 3 gives us negative 12. And like we said before again, all we're going to do is take all those things and add them together. So let's see if we get the same thing. Top left, 15x squared plus, doesn't matter what you do next, let's do 20x, minus 9x minus 12. We got to do the same step of combining like terms, but I can let you in on a little shortcut. If you're doing this box method, let me see if I can find a highlighter real quick. Nope. If you're doing this box method, the two terms that'll combine are always going to be this diagonal section like this. Pretty much every single time. Especially for college algebra, almost every single time. Those two are going to be your combined like terms, that diagonal, that positive slope diagonal. So if we combine those two terms, 20x's minus 9x's, 20 cookies minus 9 cookies, gives us, boom, 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 11 cookies in the middle, and everything else stays the same. And let's just double check and make sure we got the same answer both times. We did. We're good to go. All right, like I said, that is going to be a super recurring type of problem. It's not going to be the whole problem, but it's just going to keep happening over and over all year long. So if it didn't make sense, send me an email. If I talk too fast, let me know. If you're having trouble with any of the ones that come next, feel free. Let me know if you need to Zoom or work together on them or bring them to class, and we can work on them there. But this is a real good opportunity to practice your foiling. I will work all of these and post them too, so you can try them and then check and see if you got them right or not. Cool. So let's see. That is a total screenshot of the box method and foiling, which is the two ways we've learned to solve multiplying binomials. Thank you. See you in class.